in the second part of the lectures, I'd like to specify essentially what Georg discussed in the second part of his lecture in full generality to the case of interest for our particular physics application here, namely the elliptic and modular anomalies of elliptic genera or prepotentials or generating functionals of Gromov-Witten invariants on fourfolds in the context of fluxes, in the presence of fluxes. And then in the last lecture after the break, after the lunch, we will finally get the application to the degree. So recall that the setting that we are studying is F theory on an elliptic vibration. So we have more precisely, for specific, to be specific, an elliptic Calabi-Yau fourfold over some base B3. And the claim of the first part of my lecture was that if we consider a curve class C beta on the base, then we can wrap a D3 ring thereon to produce a string. Depending on what this curve class is, this can be a critical string or non-critical string. If this curve class is the fiber of a P1 vibration of the base D, it is a heterotic string, otherwise it would be just some arbitrary non-critical string. For this string, one can define the elliptic genus. One can define an elliptic genus of the string, I just abbreviate like this, in the sense of a trace over states with -1s inserted on the worldsheet, as discussed last time. And the claim is that this elliptic genus can be computed as the generating functional, or can be equated with the generating functional for certain Gromov-Witten invariants on the fourfold. I'll make this very precise. This is just to see and to remind you how the general flow of logic was. So I will now, to be specific, specialize to a concrete case, the simplest case that one can think of. But all of this can also be done much more generally, as we also saw yesterday in particular. So for concreteness, I will now specialize to a situation where the gauge group in 4 dimensions obtained from F theory has only a U1 factor. Equivalently, if there are more factors than just the U1 factor, we ignore all the rest. So this means that the singular fibers of my elliptic vibration, the ones that I'm interested in, are only very special ones or very simple ones, namely over a curve on the base, a curve sigma. The fiber specializes to an I2 fiber. This appeared also in the characterization last time. One of the two fiber components I will call CZ to distinguish it from the generic elliptic fiber E, and in fact E tau. And the meaning of tau and Z will be discussed soon. These are the Kähler parameters. In such a, so I will first describe the geometry and then explain why this gives rise to U1, and then use this as the simplest playground in order to make all this precise and concrete. So in such a situation, our space of 2 forms of the fourfold is spanned on the one hand by the 0 section S0, because we have an elliptic vibration. This is something that embeds the base holomorphically into Y4 as a divisor. So I have a 0 section, holomorphic 0 section. Furthermore, I assume that I have another rational section S. So for the mathematicians, I'm assuming that the model wire group of the vibration has rank at least 1. And I focus on one of these extra rational sections. So this would be another embedding of the base. So they intersect the fiber once. And furthermore, I have, of course, the pullback of all my divisor classes on the base, the alpha D in H11B. So these are the possible types of divisors which I have. If I had a more complicated gauge group, I would have more of this stuff, but I'm ignoring it.
Can you say what S is again?
S is a rational section. It's an embedding of the base as a divisor into the fourfold.
What is different to this other things?
They are two independent classes. I assume that I have two sections. An elliptic vibration can have a certain number of sections. These form a group, the model Y group. And I'm assuming that I have at least one in addition to the zero section, which forms the zero object in it. And of course, I'm always identifying the section with the associated divisor.
And the curve signal where you have the special fiber is the intersection of the F0 and S?
No, the curve, this just means that over a curve on the base, I have two, my fiber degenerates into an I2 fiber, into two fibers. So, and S0 may intersect, for example, one of the components, and S may intersect, wrap, or do other things to the other. It's not so important. Okay, so these are and this is the space of two forms, and in particular, I will use a basis that was also described generally yesterday. A useful basis will be the following. Maybe I do this here. Maybe I introduce the object tau as S0 minus 1/2 of the class of K bar, where K bar is the anti-canonical class of the base, so the first Chern class of B3. This is the first linear combination. Then dz, this will be defined as S minus S0 minus the pullback of a certain divisor class, which I'm not going to specify, a certain class, certain element in H11B3, whose specific form we will not need, hence I'm not going to specify it. And then, of course, we have as our rest the alpha, just pullback of the divisor from the base. This is a particular useful basis, and this basis has the useful property that d tau intersecting the general fiber is 1, d tau intersecting my fiber class CZ, this one that degenerates, is 0, dz intersecting d tau is 0, and dz intersecting the fiber class CZ is 1. Furthermore, they are orthogonal on everything that pulls back from the base. And these have also 0 intersection with the alpha, with everything in the fiber. So this is just a useful combination of divisors that also appeared in more abstract form yet. Just a quick notation. And the point is, if I make these three definitions, then one can understand why such a geometry gives rise to U1 gauge algebra in 4 dimensions. To this end, we have to invoke, again, a duality, namely the duality between F theory on the fourfold compactified to 4 dimensions and M theory on the fourfold compactified to 3 dimensions. M theory is a supergravity theory. It has a 3-form field. I can expand this 3-form field in terms of a basis of 1 forms in 3 dimensions and 2 forms on the internal space. And the component along this dz is the gauge field in 3 dimensions, which then uplifts to 4 dimensions. So that's the claim, or that's a general fact, well known in the F theory literature. If I consider M theory 11-dimensional supergravity on Y4, the compactification on Y4 to R12 to 3 dimensions, then I can take the 3-form gauge potential of this 11-dimensional supergravity. This is a 3-form gauge field. I can expand it, among other things, into a form of this type plus higher. So I do a usual Kaluza-Klein reduction. This is a 1-form gauge field in R12. And if I think of this 3-dimensional effective theory as the compactification of F theory on a circle, the 4-dimensional theory on a circle, then this is just the result of taking the 1 form in the original 4 dimensions. So this gives the U1 gauge field. U1 gauge field. Also then in F theory on R13. So this is a well-known fact, and in the F-theory literature, this object dz is known as the Shioda map. So we have in our effective action now an extra gauge field, this U1 gauge field. This is the U1 gauge field for which I'm going to study the weak gravity conjecture. And the second question is, when we have a U1 gauge theory coupled to gravity, do we also have matter charge under the U1? And the answer is well known to be yes. Namely, if again I invoke M theory, then wrapping in M2 brane, so this three-form gauge field in M theory couples to 2 + 1 dimensional objects, the M2 brane, I can wrap an M2 brane on this curve CZ. This gives a particle in 3 dimensions, which is the result of compactifying a particle from 4 dimensions on the circle, so doing nothing. And this is the object that is charged under the U1. So objects, particles charged under the U1 are obtained by wrapping M2 branes of M theory 2 + 1 dimensional objects wrapped on CZ times R time. This would be in R12, this would be in Y4 in the M theory frame, and again, F theory on the circle is M theory. So this gives a particle. And the charge is given by Q equals dz dot CZ. This is 1. So in other words, I've normalized things so that the minimally charged object has charge. Of course, the geometry can be much more complicated. There can be several fibril curves, but this would be the generating curve class in the fiber other than the generic class E. Okay. And the last piece of information before I finally come to the point. So we have now the gauge field of the U1. We have matter charge under the U1. And in order to satisfy the weak gravity conjecture later on, we also need the gauge coupling, if you recall. But we'll say this again next time. The gauge coupling of the U1 turns out that 1 over g mil squared is proportional to, up to normalization, to the volume of a divisor B, where B is minus my lower star dz dot dz. So I take this divisor dz, I square it, I project it to the base. This gives an element in H11 of the base, the so-called height pairing. This gives a divisor on the base, and the volume of this gives the inverse gauge coupling. So we can think of this as a 4-cycle on the base, or a divisor class dually, and always identify forms and the dual cycles. You can think of this as the 4-cycle, which is wrapped by a 7 brane in order to give the U1, morally. So its volume gives 1 over the gauge coupling square. Okay. And another piece of information, if I take my Kähler form on the on Y4, I can expand it, and I can expand it as CIDI, where this is the basis of H11 Y4, and more specifically, so I write this as more precisely, this is a complex object. I apologize, J plus ID. The Kähler form in the sense of type 2 string theory, but you can also ignore about the C. So this has a Kähler parameter d tau, tau along d tau, plus z times dz, plus a sum alpha, alpha, alpha. So the tau and the z are the complexified volumes of the curves tau, hence the subscript, and this the volume of the curve CZ. Good. Other questions about the geometry so far? So this is well known. Let's just review it, and attached with nomenclature. Questions about this? Okay. So now, in order to classify or to describe our theory, we need more. Namely, we also need to specify a background flux. This background flux is important for the physics, and it's also important for the mathematics of these Gromov-Witten invariants. So we also need to specify a background four-form flux. D4. Mathematically, this is an element in H22 of the fourfold. And in fact, for the experts, I'm looking at flux only in the vertical part of the cohomology. So forms which can be written as the wedge product of 2, 1, 1. Namely, this G4, from a physics point of view, can be thought of as an expectation value of the field strength of this three-form C3, which is known from M theory. So G4 for the mathematicians is the expectation value for the field strength of this three-form in M theory along Y4. So this is an object which is in fact quantized in a suitable way. So specifying such data is part of defining the background.
What means the half? Means like 1/2 set?
1/2 set. So yes, 1/2 set. 1/2 set. So half integral, depending on the value of C2 of 1. Doesn't matter. So, somehow 1 times. And if I may, in terms of, so H22 word, this is H11 wedge H11. So four-form classes, which are the products of two divisor classes. And it turns out that if I consider M theory compactified to 3 dimensions, I can consider 3 different classes of fluxes. And it's useful to group the possible fluxes, the possible products here that I can take into 3 classes, which also appeared yesterday. So 3 types of flux. Namely, one I call alpha tau. This would be the product of d tau wedge pullback or wedge d alpha, okay, which is a pullback from the base. The flux alpha z, which is dz wedge d alpha, and the flux, let me call it alpha dot. By this I mean the pullback of a four-form from the base. Pullback of some four-form class on the base. This is just a four-form class.
So that's just a generic intersection of d alpha.
Exactly. So that's d alpha d beta, and I can take the dual basis and call this with an alpha. Exactly. So these are the possibilities, and to match them to the notation. So I give them a label which changes, which differs by -1 from the label that was given yesterday. So sometimes I label these as a -1, 0 flux, -1 flux, -2 flux. Yesterday, this was called a +1 flux, a 0 flux, and a -1 flux. The reason why in physics one uses these subscripts is because these directly give the modular weight for the genus 0 case, and yesterday there was a different logic, but that's also, this is just to orient. Yes, in Georg lecture, yes. Georg also had 4 types of flux or of classes yesterday, which he defined very generally. This is just the result essentially of this logic, and I'm just writing it down concretely. And the point is this: what are these objects? All of these objects are defined as background values of G4 in M theory. However, M theory is F theory on a circle. Not all the fluxes that I can write down for an M theory convection also correspond to fluxes that leave invariant the full four-dimensional Poincare invariant symmetry in F theory. So only this flux, this is the only flux in F theory on R1 3 times Y4. By this I mean that this, if I want a vacuum that is fully Poincare invariant in 4 dimensions, I can only consider backgrounds of this type, and the other two classes must be 0 as a background. Whereas the other two classes can also appear as bona fide fluxes also in M theory. This is okay in M theory on R1 2 times Y4, and also in the related type 2A topological string on Y4, and this is also okay in M theory. And yes?
So what was the physical meaning?
Very good. So the physical, that was my second, that is the next thing on the menu. The physical meaning of this flux in F theory is precisely as a gauge flux associated with the U1. Namely, so the physical relevance G alpha Z minus 1. This is the U1 gauge flux in F theory on R1 3 times Y4. Meaning, I have a four-dimensional effective U1 gauge theory. I have a gauge field and its field strength. I can consider a vacuum expectation value of that field strength in my internal space. The internal compactification space of type 2B string theory, as we mentioned last time, is actually only the base. So I can view this d alpha as the vacuum expectation value of that 2 form, and wedging it with dz is just a way how to describe it in M.
It's field of the brain, or
Say again?
it's field of the
On the brain, on the 7 brains that define the U1 gauge interpretation. D alpha, I can interpret this form that I wedge in as the vacuum expectation value of the field strength associated with the U1 along 7 branes on P3. So that's what one usually means by having a gauge flux. So from the heterotic point of view, this would translate into gauge bundle data.
Sorry, Timo, I just have a very technical question for the expert. So this is like a U1 restriction. We have, from the Witten perspective, we have a D7 image D7.
Yes,
okay.
yes, exactly.
Okay.
And essentially, the relevant cycle for this D7 image D7 would be this object B, the height pair.
Okay.
Okay, so this object is important in order to really define, and that's the last bit of definition of really defining our gauge background. So in particular, the presence or not of such gauge background affects the number of massless states charged under the U1. Namely, the chiral index of massless U1 charged states or massless particles, chiral multiplets of charge 1 in 4 dimensions is given chi turns out to be given by the integral of this G alpha Z minus 1, which is to be specified, over a 4 cycle. The 4 cycle S is given by fibering the curve CZ over the curve sigma on the base, over which this degeneration of the elliptic fiber occurs. Where S is a 4 cycle, it's fibered by CZ over sigma. This is 2 of P3, and this whole object here is in H4 of Y4. So I can consider a natural pairing between the flux, which is a 4 form, and 4 cycles, this specific one. there's a natural object to pair, and that gives a number, and this gives the number of massless fermions in particular, or n equal 1 chiral multiplets of charge Q equals +1 minus the number of everything here of charge Q equals -1. So the chiral index. In the standard model, the chiral index is 3. So this is how this object is encoded in the interplay of geometry and flux.
One question. The last one, if it only lives on the base, why does it make sense in X theory? Only in them?
It will correspond to. Say again?
It's not just a bulk flux?
It is not just a bulk flux. No, it will correspond to something that is point-like in 2 dimensions in the M theory. If you track carefully through the domain ball that would couple to it, so it will break the. So this would only have a single, and this would have single dimension in 4 dimensions, and this would be a point information, as it turns out.
What do you mean by a point?
These are well-defined fluxes in M theory compared to 3 dimensions. If I lift them to F theory, they will partially break the 4-dimensional Poincaré invariant. These 2 types of fluxes. Because if you think of the domain, the objects that they couple to, and these objects that they couple to will fill some of the 4-dimensional dimensions, hence this is not a good flux to consider. If I want full 4-dimensional Poincaré invariant.
The usual thing of the legs along the door.
Exactly.
Absolutely.
Absolutely.
Yeah, we just confused because if it was in alpha, I thought it was just on the base, but it has some leg on the
Yeah, but actually 2 legs. The last one has 2 legs along the pole. And the other one is 0. So they are both back.
Okay, very good. And just as an aside, so this is the usual formula that one always writes down in this literature. One can now think, okay, I'm now integrating a 4-form over a 4 cycle. We saw something similar like this already yesterday in the definition of the Gromov-Witten invariant. There one integrated a general cycle over the pullback of a curve on the moduli space. And the claim is that indeed this object is precisely the Gromov-Witten invariant of the curve CZ in the fourfold. And one can argue easily. So a fun fact: phi are precisely the Gromov-Witten invariant. It's precisely the Gromov-Witten invariant of genus E equals 0 associated with the curve CZ in the fiber with respect to the background or the 4-form G alpha Z minus 1. Namely, the Gromov-Witten invariant, to define the Gromov-Witten invariant, the notation was that we have to specify a genus. We have to specify a certain number of points. In this case, this is k equal 1. And we have to specify a certain number of classes with respect to which these Gromov-Witten invariants are defined. In this case, I take as my defining class only G alpha Z minus 1. This object was defined as the pullback of this class onto the cycle in the moduli space of the curve in question. The curve in question is a very simple curve. It's a rational curve. It's fibered over a curve sigma. So the moduli space of this curve CZ can simply be identified with the fibration of CZ over Z itself, with 1 point fixed. And this can be identified with this object S, the 4 cycle, and hence this motivates, while this formula, which is well known to the physicists, has this simple mathematical interpretation. So this would be the pullback of, or the, this would be, I write it in words, this would be the pullback of G to the moduli space, to the cycle in the moduli space of stable maps associated with CZ, so to speak. The moduli space of CZ with one point fixed is precisely the vibration of this curve, since it's just a rational curve over sigma. So I can identify this. With integrating with flux over the curve sigma. Just as a fun application of already the terminology to this, but that's not the actual Gromov-Witten invariance that we're interested in. Okay.
Sorry, can you explain again why the modular space coincides with this S?
Because, I mean, this is a rational curve. This rational curve moves over a curve sigma on the base. Since it's just a rational curve, I take the rational curve with one point fixed. This gives me the rational curve itself times essentially fibered over the locus on the base where it can actually move in intuitive terms. So therefore,
So it's the size of this curve, basically.
it's the curve as such. It's not the size, but it can move over. I can parameterize the sigma as a locus, geometric locus. Yeah. But that just isn't. Good.
Does this agree with the mathematical calculations?
Yes, absolutely. So you can also close your eyes completely and just compute those Gromov-Witten invariants by using mirror symmetry on fourfolds explicitly and define precisely that. So this is intuitively clear, and this is checked in explicit computations. Okay, so this was to some extent fixing notation, and it agrees with precisely the data that was introduced yesterday in Georg's talk in a much more abstract and much more general way. And now we are going to look at the actual object. Recall, we still have in mind weak rarity conjecture for this U1 gauge theory in 4 dimensions. We need a tower of states. The tower of state we want to get from some string. And that string, the claim is, would be the 3-brane wrapping a curve on beta. We want to compute a partition function of the elliptic genus. And in order to do this, need to map it to certain Gromov-Witten invariants that we can compute. Namely, the claim is now that the elliptic genus is as defined as with trace -1 to the f over the state for the string obtained from the 3-brane on R11 times the curve C beta, an arbitrary curve C beta on the base. Now I need to say the elliptic genus in presence of flux, in presence of a certain gauge background. So let's specify it to whatever it is, a certain flux class that defines my background and hence will also affect the elliptic genus of the string. This object, the object that we had defined it, recall, I'm writing it again, the trace over vector with periodic boundary conditions -1 to the f, QH, Q bar H right, psi Q, where Q was the U1 generator. And here Q and psi are just formal variables associated with the wrapping of the string on the torus. This object, recall, has in general an expansion in this form as QE0 sum n non-negative R in Z n of nr Qn psi r. And the claim is, so this was the definition, And the claim is that this agrees with the generating functional of the Gromov-Witten invariant at genus 0 for a certain set of curves. Namely, this agrees with QE0 times, I write this as F G alpha Z with respect to C beta. And just as notation to write this simpler in this way, this is also a notation that is used sometimes in the literature, at genus G equals 0. So this is the generating functional for the Gromov-Witten invariant at genus 0 for a certain set of curves. So this object F equals 0 alpha beta is the generating functional for the genus G equals 0 Gromov-Witten invariance with respect to the flux G or the four-form class G for the curves C beta and R, which are just the curve C beta, whose wrapped D3 brane we call the string, plus n times the generic fiber, plus R times the curve C beta. Exactly the same object, just more abstractly appeared, of course, yesterday in Georg's lecture. Up to a normalization. I'm putting this factor of q to the E0 outside. That's the only notational difference.
The generating function of Gromov-Witten invariance usually that's the free energy, right?
Exactly, and that is the free energy of the topological A model on that on that four.
But in this case, it's a partition function. Z is equal to this.
There is a duality.
Okay.
So you can compute this in physics in two ways. The conventional one is to compute it as the free energy of the topological A model on Y4. And our claim is, or the claim is in the literature, which is a generalization of claims made earlier for Calabi-Yau threefold, that it has an interpretation as an elliptic genus of a certain string. So this object is precisely the number of Gromov-Witten invariants at genus G equals 0 with 1 point fixed with respect to a certain flux background for the curve C beta and R. This number times q to the n psi to the r, where now q is e to the 2 pi I tau. Tau, recall, was the scalar modulus associated with the fiber. And psi is e to the 2 pi I z, and z was the scalar modulus associated with the curve z that appears here. Yesterday, in your lecture, this was called P. This is, he wrote it as an intersection of certain devices with the curve. That's exactly what appears.
And Borisov and Weber calls it Y.
Awesome. Exactly, absolutely. Absolutely. In these elliptic genera, in particular Borisov, this occurs Y. And this is called Y, and then oftentimes these are different U1s from the string worldsheet. So this is for the conformal field. There is a field theory on the string with supersymmetry of 0,2 type. The ones that you described have an interpretation with 2,2 supersymmetry, and in that case there is a particular left-moving U1 that one can take as the source of the U1. I'm taking a slightly different U1, but absolutely, this is all the same.
So the first two lines correspond to some elliptic genus for some metric theory, and then
exactly.
And then the third line is the duality.
Exactly.
That you must.
Exactly. So this would be elliptic genus of the string obtained from wrapping the D3 brane on that curve. In certain cases, this is a heterotic string. In other cases, it's just an arbitrary different string, some non-critical string. This is a geometric object. This is the Gromov-Witten object. the object from Gromov-Witten theory. And the claim is, so this was the definition, and the claim is, or the conjecture, is that this elliptic genus is the same as this generating. And once more, I should say that this conjecture was put forward. So the conjecture was first put forward for Calabi-Yau threefolds, so elliptic threefolds, everything the same, except that we work on elliptic threefolds. In this case, the flux does not make an appearance. This is essentially a consequence, or was conjectured in papers by Guglielmo Lockhart, who is here, Waffa, many more, and then in many papers by many authors, Clem and collaborators, Kashani-Poor and collaborators, was studied in great detail for Calabi-Yau threefolds. And we conjectured it to hold also in fourfolds, and this also passes a number of tests. The point is that the fourfolds are relevant for us in 4 dimensions, obviously. And the flux comes in and has a much more interesting structure than in Calabi-Yau threefolds and makes then contact with these anomalies that Georg described yesterday, Jen.
What's the statement become in the case of elliptic curves?
Say again?
What happens in the case of elliptic curves? Like, does this become, does the same thing interesting?
For the case of elliptic curves, I don't have an F theory then. If you mean, if I just take an elliptic curve.
Yeah, yeah. I mean, you said that this thing was first conjectured in the case of Calabi-Yau threefolds.
Calabi-Yau threefolds, exactly.
So can you go down even?
Yes, but then you don't have an F theory anymore. So then you wouldn't have an elliptic genus left. You can then still consider the Gromov-Witten theory thereon, but you don't have, I mean, then you just have F theory on, okay, then you just have 2B theory in 10 dimensions, and there I wouldn't know what the analog of this. I need to wrap my D3 brain on something. On K3, one can put forward a similar conjecture, then one has to modify the definition of the genus so that one gets non-zero because one has too much supersymmetry, but yeah, but I didn't look at it.
In the case of the theoretic string, can this set be calculated by some integral intersection character of the case bundle?
Very good, probably yes. But this has not been worked out in full generality for those cases. So this has a number of definitions. One definition is in F theory as this object for the string, which I get by wrapping a D3 plane. Then I identify it conjecturally with this object known from mathematics. This object known from mathematics can third be computed as the topological A model prepotential or free energy. And fourth, I could invoke F for special cases F theory heterotic duality and try to identify this object with an integral over characteristic classes on the dual elliptic threefold describing the heterotic string. And that last step has, in full generality, here not been done. That's an interesting question.
So this would be a 3-level partition.
Yes, yes, that would be your tree-level partition.
The one that you.
Good.
Sorry, but the statement of this thing is not really dependent on F theory, right? You can formulate this completely without any reference to F theory. Like elliptic genus is defined without F theory and.
Absolutely. Elliptic genus of what now?
Okay, yeah, I mean, actually, yeah, I would like to ask you that question.
So this object is mathematics. The
Yes.
topological A model is topological A model. I don't need F theory for that. This interpretation is an F theory interpretation because here I'm really in the type 2B frame. I'm wrapping a D3 brane, which only exists in type 2B / F theory, to define an object whose elliptic genus I can then write.
Can one define it as in terms of some multiplicative genus of some cobordism invariant?
That would be the question that Meyer asked, if one can also on a dual that presumably there exists, or for sure there exists a dual elliptic threefold by F theory heterotic duality for certain types of C beta, only for certain types. And there this object should have such a definition, but this has not been worked on.
So sorry, the last conjecture you wrote there in the bottom, that's just a statement of the duality between F theory and type 2A, you know? So the F theory on one side and the A model topological scheme.
Yeah, I didn't write down that it's a prepotential. So the fact that between F theory and A model is that this indeed has an interpretation as the
So then the conjecture is the duality.
No, the conjecture is not the duality because the conjecture refers to the elliptic genus of a string, which has no interpretation in type 2A. The conjecture is more the duality between F theory and M theory. That's what I briefly discussed last time, that when I take the string and wrap it on a circle to go to 3 dimensions, then I get BPS particles And these PPS particles are counted by Gromov-Witten invariants.
And those are in turn the strings of type 2A. If you do this,
I'm still in M theory. So these are actually the three-dimensional analog of the Gopal-Kumar-Buffer invariants.
yeah, sure, but you now compactify one extra dimension.
Yes,
That's type 2A in 2 dimensions.
fine.
And
Yes.
for that type 2A.
Fine.
Okay.
Yes, good.
Yeah, but then, I mean, to what extent is subconjecture? I mean, if it doesn't hold, what is going wrong on the duality process? If I can think just of the M2 brain flapping the cycles and computing related to the Gromov-Witten invariant, how could not be correct? I mean, what could go wrong?
So the point is that you refer nothing. I mean, of course, it's a reality. It's a reality. But I mean, you invoke an equivalence of the theory of M theory and F theory. I mean, from the physics point of view, it's not much of a conjecture.
So that's the point. If you assume that the dualities work, then
Yes.
this should hold.
Yes. Exactly.
There's a comment that if this thing can be expressed as an homomorphism from some cobordism group, as in
Yeah.
by 100, then this would give a physical proof of your conjecture, right? Because this will prove all the modularity properties that you need from this.
Under the assumption of that, if you believe heterotic F theory duality, yeah, yes. There is in fact.
Yeah,
okay.
yeah, I said physics proof.
How are we doing with time?
So I have a question. So for Calabi-Yau, we also have all the higher genera.
Exactly.
Also have genus 1.
Yes.
Is there something similar in this case?
So you can here go up to, as you say, up to genus 1. So we do not have use for the higher genus invariants really. So to be fair, this is not understood. This is not understood. Part of the conjecture here is that one would have to do, and to that extent it is a conjecture, because what one would really have to do is one would have to argue that these Gromov-Witten invariants count BPS states from the point of view of the three-dimensional supergravity theory, and in fact an index of BPS states. In 5 dimensions, for the 5-dimensional supergravity, Gopal-Kumar-Buffer and Clem-Katz-Buffer defined carefully a certain index in the 5-dimensional supergravity sense, and identified it with BPS invariants, which then in certain cases directly on the nose agree with the Gromov-Witten invariants, and in more complicated cases are related to them at genus 0. And the conjecture is that the same genus 0 is also the relevant object simply to consider here. But what is kind of missing is a precise definition of this index from the 3D n = 2 point of view of the M. So the genus 1 object would count certain different states which are not featuring in this elliptic genus. Also on Calabi-Yau 3-folds, here it is on the face, the analog of this is only the genus 0. Of course, you can then complete this at higher genera, and take the full object. What the analog of this object is here on fourfolds has not been worked out.
So sorry, this is very interesting. So from the F theory point of view, we may say that this is because these curves are always rational curves in the end, no? The ones that are associated with the flux, with the matter. So
but only for the lowest multiplicity. The higher multiplicity objects, which I get at higher values of n, will
with a different genus.
will appear with a different genus together with arbitrary powers of the full fiber class. So this will be an object of a very high genus. But of course, what's relevant for us is the genus of the Riemann surface that underlies the stable holomorphic map. So this was we thought about this for some time. We couldn't really make this well defined from the 3-dimensional supergravity point of view, but maybe it's worth revisiting. So that's why we put it forth as a conjecture in that sense.
So in genus 0, there's no holomorphic anomaly, right? So
there is, yes. We'll come to those now. There are the whole structure of anomalies that we saw yesterday is at work. Let's see where we are. Okay, maybe it is time. By the way, just as an aside, so the claim is that this is an object of modular weight -1, and index M. So this behaves like a quasi-Jacobi form of weight minus 1 and index M. The weight minus 1 is a consequence of us allowing only for this particular type of flux. Had we chosen also the other two types of fluxes, we would have gotten weight 0 and minus 2, but then we would not have an object defined in F theory, but only in type 2A. So mathematically, of course, one can write this down, but not in this four-dimensional F theory. And the M and the E0, just as an aside, Georg gave the formula yesterday, but they also have a physics interpretation. The E0 is given by the intersection of the tau dot the curve on the base that is wrapped by by the three brane. Maybe I should write it like this. If I view this as an object in H2 of C3. And this turns out to be given precisely by -1/2 k bar dot CB now on the threefold. This is precisely the Kaluza-Klein charge associated with an M2 brane wrapping only the base curve. And this is to be identified with this 0-point energy. And this reproduces precisely the factor that Georg wrote down yesterday. And this M, the index, has an interpretation as the 1/2 this height pairing with C beta in physics language. This was this height pairing pi lower star dz with a minus sign. And this controls an anomaly on the world sheet, the U1 anomaly on the world sheet of the string. That's just as an aside. So the important point is just that these two input parameters, M and E0, have a geometric form and a clear physics interpretation that I'm not going to discuss further.
The first line, it says d tau times c beta.
Yes, exactly. Okay, that's just as an aside. And now let's come finally to the amazing story of these anomalies that we saw yesterday. So in the interest of time, I'm not going to write down the full form. So now one can consider now the full form of the modular and elliptic anomalies for the generating functional of the Gromov-Witten invariants by the conjecture. If I identify the Gromov-Witten invariant generating functional with the elliptic genus, the modular properties should be the same. Since for the Gromov-Witten potential, we expect a modular and elliptic anomaly, we also expect one for the elliptic genus. And that would be of a form more drastic compared to what was studied on threefolds. And one can view this now as two ways. Either one takes this complicated machinery by Oberdijk-Pixton and applies it to the special case of Calabi-Yau fourfolds, or equivalently, one can derive these, for the special case of fourfolds, one can derive these modular and elliptic anomalies in physics language by a generalization of BCOV using topological string. This was already giving an explanation of the modular anomalies on threefolds, and one can do this also on fourfolds. And the form of the anomalies that one gets agrees perfectly with the specialization of Oberdijk-Pixton to fourfolds. Either way, the result is the following. First, we have an anomaly to the extent that we have that the object that we get is not just a Jacobi form, but has this object E2 in it which yesterday was called, which up to a factor of -24 is the G2 that appeared yesterday. So we have a dependence on this of this object G alpha Z -1 C beta, this Gromov-Witten potential, and it can be written explicitly as follows: -1/12 times sum over all classes C beta 1 and C beta 2 on the base, which sum up to the original C beta. And we take the Gromov-Witten invariance or the generating functional G alpha Z on C beta 1 times the Gromov-Witten invariants with respect to a certain background flux, and the background flux is given by pulling back the class of C beta 1 interpreted as an element in H4 of the base to the full fourfold of C beta 2. That's for this special case at genus 0, the anomaly equation. So this means.
So what is the superscript of G alpha Z?
G alpha Z.
Oh,
Yeah, G alpha alpha Z. This was this background flux associated with U1. Once again, G alpha Z was, let me write it here, G alpha Z, recall, was dz, this divisor which intersects the curve CZ, wedge pullback of a certain divisor alpha from the base. Okay, so this means that one has such an modular, such a type of anomaly whenever the curve, whose string we consider, whose associated string we consider, whenever this curve splits into a sum of two holomorphic curves. So when it's not a generator of the Morricone by itself. Then we have a dependence on E2, and this dependence on E2 is governed by these two factors. The first factor are the original Gromov-Witten invariants of one of the curves with respect to the same flux. The second one are the invariants of the second part of the curve with respect to a four-form of this type. So recall this here is an object, a curve class. So I can view this as an element in H4 of the base. And I can pull it back, then it's an element in H4 of the fourfold, excuse me, in H22 of the fourfold, and the associated invariant and its generating functional can be computed.
So in the lecture of yesterday, there were three terms, probably the other two.
Very good. The other two vanish for the case of genus G equals 0 and for this particular flux. One can do the same thing also for the other two fluxes, then more terms appear. This is really for the special case. I'm restricting now for the special case genus 0 and for the special flux G alpha Z minus 1.
But maybe G equal to 0 is enough to keep the first term, I guess, because it was depending on G minus 1. It was the sum.
Exactly. But then there are, for the other types, there will also appear an interesting descendant term that involves these tau descendants, these gravitational descendants of the invariants. And this is absent for this one. But it's not absent for the second, and this is even more interesting. So this one has a clear analog on Calabi-Yau threefolds. This is a famous holomorphic anomaly of the topological A model on Calabi-Yau threefolds. It occurs whenever the class that we are looking at splits into sums of classes. What has no analog on Calabi-Yau fourfolds is the fact that we also have a dependence on E1. E1 was the object that yesterday was called A. This implies a more severe deviation from modularity. And in the present case, under these two restrictions, the dependence on E1 is governed by invariance with respect to a four-form class, which is pullback of this B dot d alpha beta on C beta, where the alpha beta was defining the flux, and the B is the pullback of, is the push forward of the TZ. I could also write it directly. Yeah, I wrote it directly in this form yesterday. Never mind. I'm writing it here like this because this object B has a meaning in physics as the volume, as the cycle wrapped by a 7. So that's what appears directly. So this gives an appearance directly on this Jacobi form U1, which would, written non-holomorphically, induce a dependence on the ratio of Mz over M tau. We call these E2 can be completed into a into a Jacobi form, which is non-holomorphic, almost holomorphic. Then we have a dependence on M tau here. If one does the same for E1, one gets Mz over M tau. Mz over. Yeah. Okay. So importantly, now also compute dE1 of E1 of this F. So this would mean that we need to compute the E1 of the invariance with respect to a pullback flux of this type. And this vanishes, as it turns out. Again, for the special case we are considering. Therefore, we get a dependence on E1, but only linearly. And this simplifies our life a lot. If I have maybe just 3 more minutes, then I can finish this off. So E1 will appear only linearly. In other words, our prepotential and hence also our elliptic genus can be written as something that in physics we sometimes call a quasi-modular form. I don't think that this is an object that actually exists. So this would be an object that is a Jacobi form or contains a factor of powers of E2 plus something linear in E1 a tilde quasi-modular of weight minus 2m, because this has weight plus 1. So where my quasi-modular is a Jacobi form which contains powers of E2. Let me write it in this dirty way. So this I think is still a ring that would be generated by the Jacobi forms together with the generated E2. But E1 appears only linearly. And why is this important? This is important because one can use a well-known identity that relates such products to total derivatives. Let me just quote this identity. You saw this identity operator yesterday at various stages, and an identity is that if you take a Jacobi form or something that also contains powers of E2 that doesn't change the argument, then the total derivative thereof can be written as a meromorphic object, w minus 1 m plus 2 over phi minus 1, 2, one of the generators of the ring of Jacobi forms, plus E1 times phi omega minus 1 m. So solving for the other side, one sees that up to the issue of meromorphicity, which is not a problem, however, because we have something meromorphic anyway. The only deviation from the appearance of E2s is via total derivative. So f g alpha z c beta is of the type quasi-modular minus 1m plus psi of something minus 2m. Of this form. And beginning from this representation, we can then in the next lecture, in the final lecture, use the modular properties of the two building blocks as essentially a Jacobi form up to E2, which is harmless, and something which is a total derivative of a Jacobi form up to E2. Can use this to deduce the presence of certain states, of a sublattice of states, which then satisfies the gravity conjunction. But in order to do this, the appearance of this term, and hence of this modular and elliptic in particular anomaly, was crucial. So we will continue from here next time, after the break.
Okay. Any very quick question? And then we go for lunch.
So do you assume that the index is non-zero here?
Say again?
Do you assume that the index is non-zero?
Yes, I'm assuming that the index is non-zero. Thank you.
Nice. Okay, so let's thank Timo again and